Alrighty then, let's talk concurrency control. Now, this is something you've touched on again before in your SQL work, right? With databases, you added a timestamp, and in stored procedures, you would check to see if before you edited a record, if it had been modified by some other user. By the way, of course, there's more than one approach to that, right? You've talked in the past, I believe, that you could do a compare all values approach where you compare each, field with its first name, last name, et cetera, and see if the old value and the new value are different and things like that. But a timestamp is a nice, efficient way to do it as long as the database supports a timestamp, which SQL Server does, right? So that's the approach we're going to use today. Just before we get into the demo, I just mentioned here, I put up a comment. Remember I had an issue the other day with the formatting of my little pop-up tooltip, right? The title actually showed, but it wasn't formatted on the other views. So I put up some explanatory notes on the lesson in Blackboard, but just in case you missed that, just mentioning that what it was I had just had a brain fart and forgot, this little snippet of JavaScript needed to support the Bootstrap tooltip, right? So I had it correctly here on the patient index. I didn't have it on the doctor and the appointment one, so I just had to put it in place, and now they're all formatted nicely, and away we go. Yay, good stuff. Okay. Before we go on, I hope you just watched that lesson. I talked about why we would go to database.migrate, because that actually forces it to use the migrations and go through them instead of just recreating it based on the current state of the model as reflected in the DB context, right? Because going forward, we want to guarantee that if we manually add some code to the migrations, that's what gets used. Of course, it would if we did an update database manually, but this is a way to get it done automatically as we call our initializer, right? Okay. Okay, so I'm going to close that for now as well. So let's talk about concurrency. So here's my little copy paste file, right? So a timestamp for concurrency is all we really need. And you know what? The system is so smart. We don't have to go in and write stored procedures that say, hey, compare the timestamp. Entity framework code does that, right? So I'm going to just use the patient model. Okay, so coming up here to the models folder, I'll just use patient as an example. So I can stick this, as you know, anywhere, but I usually stick things, right before maybe the foreign keys if I'm adding something new. So right here after email, I'll just throw this code in. Now, it's mentioned in the copy paste file that, this kind of thing, adding this timestamp or row version, I'm using the name row version, but notice the annotation is timestamp. That's what tells Entity Framework Core to actually do the concurrency, right? This annotation here. So that's why it actually works. But I could put this instead of in the individual classes. Where else might I put it? I might put it right in here. Not in the interface, right? But in auditable. I could add it as an extra property in here. That would be done if I was going to live with the assumption that every single entity that's important enough that it needs to be auditable should probably also have concurrency. And if that's true, then that's a nice easy way. I don't have to go around manually adding this extra property just in select entities, right? If it's going to be an audible, then everything that's auditable will also enforce concurrency control. It's not right or wrong. It's just a different approach I wanted to make sure you're aware of. For now, I'm going to say, you know what? I think it's only the patient that I'm worried about. I mean, you don't edit doctors very often, right? And things, or whatever my excuse is, or sorry, my reasoning for doing it just in patient, but I'm going to demonstrate it this way. Just be aware that that could be an option you would do. Okay, so we've added a new field here, right? And of course, I'm going to have to do a migration, right? Okay, so let's add a new migration. So I'll come up here, I'll get my common commands nice and handy. I'm going to add a migration for my concurrency. Bring up the package manager console. Obviously, I was mucking around in here earlier, but that's okay. And I'll call it patient timestamp. And that's all it's going to do, right? Oh dear. Okay, why didn't that work? Well, I was mucking around with this example earlier, and I suspect that I probably have it already in different, and it, anyway. All right, it should have worked. Sorry, maybe what I'll do is I'm going to go the route of starting my migrations over, right? So if I delete the folder, delete the database. Sorry, trouble was I didn't save a copy right after auditing before I was messing around. So I was trying to back up there. But anyway, here we go. So now I don't even have the migrations. So using my common commands, I'll start a brand new set of migrations here. Oh no, I don't want to do that. Uh, Boy, you're really seeing me go through the hoops today. Let me delete that whole folder. What I'm going to do, come back to patient. I'm going to comment out this one for now. So it's as if I haven't added the row version yet. Boy, lots of practice here working in the package manager console today. Okay, so I'm going to add my initial migration. Now it does not have, right, the patient, okay? I could even do an update database at this point in time if I wanted to, right? Update database without specifying a migration, it'll just do all of them. Of course, there's only one. There we go. So I've updated the database. All right. And actually, you should, whenever you add a new migration, you should always actually do an update database because that then updates the migration history file within the database. Okay. Now, coming back to patient, I will uncomment, right? So I'm putting it back in place. Just save that change. Okay. Coming back here. Now I will, oh, I can bring back previous commands. There's my add migration for the patient timestamp. And this time, cross my fingers. There we go. All right. So the up is just to add the column for the row version. Notice the data type in SQL Server is a blob, right? And the down, we're just dropping that column. Okay. So that's good. We have that in place. Let me bring back my copy paste file because I have some explanatory notes in here, right? Okay. Don't update the database yet. Well, see, we've added a new migration, but I have not actually done the update yet. Okay. We're going to get to that in a second. All right. Timestamp data type in SQLite. Okay, timestamp or row version, we don't actually have the same kind of field. It's actually, remember, we created a field called timestamp inside SQL Server. Well, we don't have that here. In SQLite, we can, and feel free to follow this link. This is where I got this whole approach from, this little explanation here. We can use a blob, right? A binary large object, okay, holds binary data and a large object, right? So it'll nicely hold our byte array, okay? Remember what a byte array is. It's using hexadecimal characters to represent big, long numbers, throw them all together, and that way you can represent a big number in a small number of characters, right? Okay, so our code for concurrency will not catch concurrency errors just by having the blob field there, and even with annotating it as timestamp, right? The reason why is the field never changes, okay? SQLite, unlike SQL Server with a timestamp, it automatically updates it every time there's a record is created or updated, right? We have to make sure that happens ourselves, right? We can do that. How? With triggers, right? So basically it involves adding code. You know, this is the approach shown in this particular tutorial. That's what I've been doing for some time now. Adding code to the migration, right? To call our own code that will create triggers, okay? And then we'll make sure that that happens every time we apply migrations, right? So we're gonna have, I don't want to go in and actually edit the migration file, although really at this point it probably wouldn't be the end of the world, but this is the way I've always done it. Keep it separate, right? I'll make a separate little static class here with a static method called steps. So I can call extra migration steps. Gives me a little chuckle whenever I say that. Extra migration steps, okay? We pass in the migration builder and we can use it to execute our own SQL this way. So I can have my create table statements here, right? Because of course we want to have one for the update and one for the insert, okay? Both on patients, okay, where we assign a new value to the row version, okay? And just the one row, of course, identified by the row ID that's come in, right? What do we update it to? A random blob, okay? That's built into SQLite, just creates a random binary large object, right? Could we ever create two the same? Well, I cannot sit here and say it's impossible, but I'm certainly not going to lose sleep over it, right? So just, I know with a timestamp, it actually increments it, right? This isn't the same approach. It just makes a new random one, but they're so big that I'm not really worried about having a duplication, right? So this is what we're going to do, and just watch as we actually go through and do it, right? Okay, so what I'm going to do is come to my migrations folder, or the data folder, I should say. I'm going to right click, we're going to add this class. I'm going to call it extra migration. Okay, and I might as well just copy and paste the code. So as I said, it's going to, let me close this for now. It's going to be a static class with this static method steps. We pass in the migration builder, right? And we're just going to execute the SQL to create our two. Notice even the name set patient timestamp on update, on insert, right? Just to give it some unique names as well. Now, if I had added, for example, the timestamp into more than one entity, right, doctor as well, for example, well, then I'd have to create two more triggers. So I could copy and paste and make the changes, right, to reuse this code. But I'd have to make after update on doctors and after update and so on. So, bottom line as well, if I stuck it in my Audible class, then I have to make sure I remember that if I inherit from Audible on any new entities I add to the system, I'll also have to go in, because there'd be a timestamp in there if I had added it. I'd have to go in and actually add triggers for each and every table where I'm going to do this timestamp concurrency control approach, right? But I'm just doing the one for now, so that's good enough. So how are we actually going to call this? Well, remember, just let me back up for a second, that we're making sure that we're calling all of our migrations. So this is the most recent one, right? So this has everything in place I'm going to need. So in here, I can just call my extra migration, right? And I have the model builder I'm already using, or sorry, the migration builder, right? Okay, so just before I'm done the up, I'll call X migration steps, right? Now, if I had this earlier on, it probably wouldn't be a good thing, right? Because I need to have the row version column in here, right? So yeah, there's a little bit of, you got to be careful, right? It wasn't, to be honest with you, it wasn't so much of an issue the way we were doing it up to this term, because we always followed the same approach. The limitations of SQLite mean we could only ever have one migration, right? So I would just, if we had to make a change, delete the database, delete the migration, recreate the initial migration, and I'd stick it here at the end of the initial migration. Done, right? No worries. Now I do have to think about making sure I call this, probably the last thing I do in the last migration I have, right? So that's another worry we're going to have going forward, making sure I call this in the right place. But now I could update the database, or because my medical office initializer calls migrate, it should actually do it for me. Okay? Okay. But you know what? Before I even do that, let me just digress for a moment here and talk a bit about this. Okay? So yeah, now I can update the database. Actually, you know what? I am going to. I am going to. I changed my mind. Hey, that's a man's prerogative. That's what I keep reminding my wife, right? Okay. And we see it creating our triggers there. Yay! We're all good. Okay. So it is good. It's done. And, it's up to date now. So even if it hits this migrate, it's going to say, hey, what? I checked with the migration history table in the database, as long as they don't delete it, right? And it won't actually apply anything because everything is up to date, right? Okay. All right. So we're all good. We're ready to go forward there. But here's my warnings. Warning, 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 right? Uh, We want to make sure we run update database to make sure it happens. Okay. It's not enough just to call ensure created. Okay. Well, we actually had that whole lesson just a few minutes ago on why that doesn't do the job. We want to call migrate because ensure created bypasses the migrations. And if the only hope to get our triggers created here, if we make other changes or are just recreating the database, okay, then we have to make sure we actually call .migrate, right? So a note here, ensure created is approach that completely skips the migrations pipeline, okay? And no, so we have to be very, very careful of that. We have to be careful when we call our extra migration steps as well. Ooh, look at this. I have an alternate approach. Now, this isn't necessarily better, but I thought I should share this, okay? instead of creating the triggers in the migration, remember that we executed some raw SQL right in our initializer when we were seeding data. Okay, I'll remind you where that is. Let me move this off to the side for a second. If I scroll down here, since I'm in the initializer anyway, way down upon the Swanee, no, it was right here. Okay, after we seeded all these extra doctors. Now this, I should want to clarify because a student actually asked me about this. He thought, oh, this is something I'm supposed to do. Every time I know there's no related child records, I should go and delete entities. No, no, sorry, I never wanted to give you that impression. So please don't infer that from what I'm doing here. This is only seed data. And it just seemed to me that, hey, I've added all these, wonky names for doctors, and half of them don't have any patients, right? So why not clean up the system and remove the doctors that I'm not using, okay, of this crappy seed, I mean, this artificially generated seed data that I have in place. It's not something I encourage as an important practice to do. I just thought, hey, it's something that the seed data is meaningless anyway, so I have a whole bunch of doctors that don't have patients, right? And besides, it was a chance to demonstrate this: execute SQL raw, right? Showing the fact that we can actually still, even though we're working with migrations and any framework core and has so many capabilities, we still can roll up our sleeves as developers and say, you know what, I want to execute some good old fashioned SQL, right? So following that approach, oh, sorry, let me finish. Yeah, so I apologize to the student that had a wrong impression. You don't have to feel you have to go and delete any parents that don't have children in any entities, especially like this is a one-to-many, but especially in a many-to-many, you'll often have parents on one side or the other of a many-to-many, and there's no corresponding child records yet, right? But they're there for future use. Okay, anyway, I digress. Back to the point that we can execute raw SQL. So this is another place if you're going to do this kind of coding, again, do it at the end, right? Right before the catch block at the end. Here is where, at the end of the try, is where I would put this kind of code, right? So let me just throw it in. We're going to follow the same approach as that earlier code we did with doctors, right? I just define in a string the SQL command I want. Of course, I love this, right? It allows me to get all kinds of wonky, funky stuff in here in my string, and it still works, right? So these are the exact codes, except you notice this, I added this for safety, right? I added drop trigger if exists because, hey, if I already have it there from a migration, right? I don't want to crash and burn because I'm trying to create the trigger and it already exists. So that's why I put it in for this demonstration. It's not a bad idea to have it there anyway. It just means that, hey, I'm about to create it, so I'll drop it if it's there, and that way I don't crash and have an error coming up stopping me from running, right? So with this in place, I don't need it in the migration. Is this a better approach? Well, maybe in some ways, maybe not in others. Okay, there a warning here, right? At some point in development, we usually stop seeding data, right? We might stop using this medical office initializer. Of course, if that's the only way we're getting our migrations enforced, then that wouldn't be good either. But we often stop using these, right? So, it's if this is the only place where we create the triggers, then that's something we have to be aware of. So it's a warning, right? You got to think about how these triggers are going to be created as long as we're using SQLite, whether it's going to be in the migrations and make sure then the migrations are applied, or if you're going to do it here in the initializer, right, where we seed data, that's okay. Now, as I say here, I suppose if we get to the point that we decide to stop seeding data, right, then you could just comment all the actual seed code, right? All the code that we have above, and just leave this code where we're actually creating our triggers, right? So anyway, one way or another, right? I'm going to leave both for now, right? Because this will drop and recreate the triggers. I'm doing extra work that's a waste of time because of my extra migration already doing it. But, you know, uh, think of it as double insurance. No, I don't encourage you to leave it this way in the real world, right? It should be in one place or the other. But just for demonstration purposes, I'm going to leave it here for now. Okay. All right. I get down off my pulpit now. Again, you could comment on all the seed data. If you no longer want to seed, you have, you're applying this against something that has real data you don't want to actually take a chance on losing, etc. But for now, this is going to get the job done. We have two different approaches. Okay, there's warnings that go with each one. So just be sure you understand what you're doing and some way or another, you want to get the triggers in place. Okay, now let's actually start using the row version, okay? So maybe I'll actually close all these tabs so we can start fresh. What we're going to do, we're going to focus on patient. So I'm going to need two things, right? Down in the views, I'm going to need the patient edit view. We're only focusing on edit right now. Coming up to the controllers, I'll need the patient controller, right? We need to have access to the row version. So right now, it's just another property. So when we go, for example, down here in the controller to our edit get, okay, we're going to go and we're going to get the patient, okay, we're including all this other stuff, but it's going to contain whatever value the row version currently has, right? And it should have something, right, because of our triggers. Ooh, you know what? You wouldn't have, yeah, it's okay. It'll work. All right. So it has it there. And we return the patient model to the view. We want to make sure that it gets stored there, right? Because only data that gets stored in the view will come back from the view. So how do we do that? Well, coming to the view, it's pretty much the same situation as this. Remember, we had this right at the top inside the form, okay? It's a hidden input for the primary key, right? We don't have a uh, uh, an input control, right, for the primary key, not when it's an integer identity. There's no point in even showing it to the user, but we have to make sure that somewhere inside the form it's tucked away, so when we submit back, it's among the other form parameters, the data that comes into our request with the request, right? So I could even just copy this, paste it in, and have another hidden input for what? For row version. There we are. Bada bing. Okay. All right. So now I have my get. Okay. I send the patient down to the edit view. It will be stored here. And then when we're done editing, we click the submit button and it's going to come back to where? It's going to come back to the post, right? So down here, I need, I need a parameter, right? Yeah, it'd be in the data anyway, but I might as well have a parameter so I can access it directly, right? So what kind of an object is it? We know that. It is a byte array, right? Called row version. Okay, so now we have it here and we can work with it as we prepare to actually complete this edit operation. Now, one of the things we have to be aware of, just to kind of talk a bit about it for a second, remember when we, in the edit process, when we go and get the record from the database, we do not use that as no tracking, right? We want the change tracker to be active, so it'll have the old versions or original versions of all the properties stored in the object along with the ones that we're going to be able to edit, right? Okay, so down here, right before we do our try update model, okay, make sure at that point in time, or at least before it, we do one extra thing. What we need to do is make sure we're comparing apples and apples here, right? So our patient to update came from the database, right? The row version property of it, okay, we want to make sure that, remember, it has the original values and then just dot value, right? We want to make sure the original value is the same as the one that we stored in the view, right? Otherwise, we're not comparing to the same version of the record. Okay, because this could have changed. Somebody else might have edited it as well in the meantime. So we want to compare to the version that we got when we pulled it from the database. So that is this row version. So we set that to the original value. Then everything else in terms of the concurrency is automatic. Whoa, you gotta love Entity Framework, right? It's so smart just having the annotation. Hey, this is a timestamp, so it will do it. And you know what? This has been here right from day one or day two, whenever it was we first scaffolded a controller. This has always been there in our edit post in all of our scaffolded controllers. A catch for DB update concurrency exception. Now we've never hit it because we've never had anything that would be there to do concurrency checks, right? So now we'll actually be able to hit this exception for the first time. Look at the logic here. We call patient exists. What is that? Well, it's always been there as well. At the bottom of every controller, there's had one of these little, doctor exists, patient exists, whatever. Just check whether or not there you get dot anything back when you query for the primary key, right? That's all that is. Okay. So if it doesn't exist in the database, then it's just returning a not found, else, we're just throwing the exception. Well, we don't want to just throw exceptions, do we? So we're going to handle that at least in some way or another. Now, the short and quick way to do it is just give a message back to the user, and we can take advantage of how all of our messages are showing up. We'll add a model error to the model state, right? Now, the first parameter, of course, is where it's going to show up. Okay, so string.empty is the same as just a pair of empty quotes as shown up here. Same thing. It means it'll go in that summary at the top. Just to remind you, since it's open, remember that's this div up here, the validation summary. So that's where the message will go, right? I can just say, the record you attempted to edit was modified by another user. Go fly a kite, right? There we go. And that's it. That's enough to tell them, okay, that there was a concurrency error. And they can click save as many times as they want. It's not going to be able to save, and that's that, right? Let's test it. Okay. So I'll bring up a patient, pick any patient. I'm going to pick the first one here. Now, if I right click and open a new tab, right, and just click edit here, then I've got the same record in both, right? And if I view source, for example, down here further, okay, here's the actual data. See that, right? Can I make this font bigger? Yeah. So that's the actual data representation of our byte array. So these are all the bytes that make up the byte array, representing that big digital number that's actually stored in the background, right? Now, if I do that on both, okay, you'll see that I do have exactly this. I'm not going to take time. The exact same value in each one, right? Oh gosh, that's a little big. Yeah, that's good. Okay, so let's do an edit. I can pick one or the other. Maybe I'll take this out. Oh, that's the wrong birthday. It was the first, right? And they're going up to 7 visits a year. Got a new phone number, whatever, right? Whole bunch of changes, click save, and that worked, right? So this is that new version with the new phone number, everything else, right? Good. Come back over here. I'm just going to change one thing, assign them to a different primary care physician, click save. Ah, the record you attempted to edit, right? Modified by another user. So it worked. Our concurrency control is working. Yay! Are we happy? Well, we should be. We have something that's normally very complex, relatively easily done and in place. The only twist was having to do those triggers, right? Other than that, it was extremely easy to get this in place. But, we can do better, right? This isn't a very clear message, and I could click here and click save a million times. My only choice is to go back. Now, if I click edit again, I'll get the same record back, but the revised version, the version the other person had saved, right? Okay, but I was stuck where I was. We can do better, as I said. How? We can give even more feedback, right? So what I'm going to demonstrate now. Now, this is a fair bit of custom code, and yes, I don't know of any shortcut at this point in time to get around doing this kind of work, but you only have to do it in the one spot, for any entities that you're actually going to do concurrency control on, right? So let me just replace the entire catch block here with a much bigger version, but don't get scared. It might look like a lot of code, but it's not difficult code, right? So same thing, our DB concurrency exception, we're just giving it a variable to work with so we can actually access all the good stuff it returns, not just note that we had the exception, right? So we can go into the exception. It has entries. Now we only want the one that'll be there, right? And that's going to be our exception entry. And once we have that, we can grab the entity out of it. And guess what it is? It's a patient, right? But we have to actually cast it as a patient object. And that gives us this guy here, our client values. So that is, let me emphasize, this is the patient object that we were trying to save. This has all the data that the user has made any changes. This is the version that is up on their screen right now that they were trying to save. That's our client values. Okay, that's what's sitting in front of the client that they want to save. Now we can also go back to the exception entry and we can get the database values. We can get all the values from the database as well, right? And before we even try and casting it as a patient, I can just first of all see it, is it empty? If it is, then this record does not exist in the database anymore. So we're handling that case, right? Are adding our model error to say unable to save changes, the patient was deleted by another user. So between when I clicked edit, right, and brought it up on the screen, somebody has deleted that record, right? And it's no longer there. Okay, else. So it is there. So now we'll go to the database entry and we'll basically convert it into a patient. We have to do a to object, cast it as a patient, and now we have the matching. Our database values is yet another version of the patient, but it's the version this currently stored in the patient. So client values is the version of the patient on the screen in front of the user. Database values is what's stored in the database right now, right? Then we just have a whole bunch of ifs where we compare, comparing the database value first name to the client value first name. If they aren't the same, then once more, we'll take advantage of our model errors, that whole framework that's already in place. Where do we want the error to show? Well, obviously beside the first name property, right? And we can show current value, and all I have to do is pull out a database value as the first name, right? And that's it. Middle name, last name, okay? The OHIP number, that's all the same down here. The only twist on the date of birth is if I'm going to display it, I don't want to have the whole time component showing, so I'll just do a string format for a date, short date format, right? Okay. Phone number. Hey, remember, this is a fully formed patient object according to our model class. So it has all of our summary properties too, right? So for the phone, I could use our phone formatted to make a nice friendly display with the brackets and dashes and spaces like we like to show phone numbers, right? Email's fine. It's just simple and away we go. Same with our expected yearly visits, right? And there we are. And so all that is taken care of to there. Now we come to the trickier parts, the foreign keys, because all that data was contained in our objects, but we haven't been able to include related objects in this process, nor would we really want to, right? So if the doctor, the foreign key, the integer identity that's the integer, I should say, for the foreign keys that are saved inside these two versions of this patient don't match, then they have changed, okay, the primary care physician, right? So we have no choice. Okay, we can't show a user-friendly version of the doctor's information without going to the database. So we have to go context doctors. First, our default, go and get this one doctor, okay, where the ID matches our database values. Bada bing. Now we have that doctor, the version of the doctor that's in the database, okay, and now I can add the model error to show right under what? Underneath the select for doctor ID, saying current value. Oh, but of course, our doctor is a fully formed object, so we can use the summary property full name. Okay, this is just in case we didn't get one from the database. We don't want to crash, so we use the Elvis operator. All right, same thing for medical trial, almost, except remember, this is a nullable foreign key. So if in the database there is no value for the medical trial ID, then basically it's null, right? In which case, to try and go and get it from the database would be a waste of time and would probably raise an error. So since it's null as a nullable foreign key, all we'll do is we'll add the model state error saying, hey, guess what? Medical trial ID, right under your select, show current value, none, right? They are not in a medical trial. And none kind of harmonizes with the prompt we added at the top of the select list earlier on, right? Okay, now, of course, if there is a value, we do the same thing we did for doctor. Go to the context, the medical trials, go find the first or default one, store it here, and then we show it, okay? Current value, and we show the name using, of course, the actual trial name property. That's it. Then we have our summary to go up at the top. Okay, this appears in that validation summary. Record you've attempted to edit, right? If you want to save your version of this record, click the save button again. Ooh, wait a second, we couldn't do that. A few minutes ago, I tried, I clicked save over and over again, and I could not save it. So what are we doing here to allow that to happen? Okay, notice it explains as well. Otherwise, click back to the patient list, okay, to just go and give up on saving your changes, right? So this works because of this, right? We're going to set the row version in our patient update. Remember, that's the one that we're sending back to the screen in a moment, okay, for the user to get all this feedback on, okay? We're going to set it to the row version that came from the database, right? That way, it's no longer will be seen, it will no longer be perceived as a concurrency error because we've lied. I mean, yeah, we've lied. We've told the system, okay, this is the version that we're happy with. So now when they save, because notice we have to remove it from the model state as well, but when they save, it will no longer be seen as a concurrency error. All right. Okay, let's just actually run this and see the difference in the performance and the amount of feedback that we're getting. Oh, I forgot one thing in the bottom of my copy paste file, right? Just a note here that the span, right, is missing, right? Right now, the validation message for medical trial, that nullable foreign key, we didn't have one because we didn't need it earlier. So we'll have to add that back in, but I can do it while we're running anyway. So let's come in here to patients, right? I'm going to get set up. Actually, before I do this, let me make that change. So let me come back to Visual Studio, right? So if I come to the edit view, okay, Quick reminder, if we're down here in the foreign keys, you'll see for the doctor, we have this span, right? To show any error messages, model errors related to the doctor ID, the lookup. We don't have that up here. Why not? Well, we didn't need it, so we didn't bother adding it, but we do need it now. We didn't need it before because even with our none option, okay, which would give the null value, well, that was fine. That was allowed. It was a nullable foreign key, so there was no need. However, now we might want to show a message about when to give details about a change that's affected with concurrency, right? So don't forget to change that to ASP validation for medical trial ID, right? Good. Okay, I'll just save that. Just click this. So we've reloaded our our browser with this latest version of the view. Now we don't even have it on the screen yet, but I will in a moment. So I can pick the same person just because they're easy to find. Open in a new tab, right? So I'm going to give a middle name back again here, right? Remember we took it out earlier. So this user A or left, yeah. No, it is the 15th. Boy, you keep messing that up. And they're only coming twice a year. They're pretty healthy, right? A new phone number, right? Away we go. So lots of changes here. I'll just click save, and there we go. And that's successfully saved. Now we come to user B, right? Oh, you know what? We have the OHIP number wrong. Okay. They have a different email now. They've switched and they're using Hotmail, which actually is Outlook. But anyway, you get the idea. I'm going to change the medical trial, right? And we'll change the doctor. And, I'm going to change something I'm changed a moment ago too, to a totally new value. Right? Remember we changed it from 7 to 2. Well, here I'm going to say it's going to be 8, right? Okay, I click save, and there we go. Look at that nice, clear explanation up top, right? And it's showing all the differences. Now, the ones that are the same, there's nothing said, right? But all the ones that are now different, okay, it's showing me the current value in the database is 2, right? I'm trying to save 8, so on and so forth. So I can look at all these differences and you know what? Oh, okay. All right. Well, somebody else, between when I clicked edit and got my copy of the record, all of these changes have been implemented, right? Okay. See, current value is none, but I'm assigning them to this and so on. But if I'm happy, if I look at all this and say, you know what? I'm okay. I don't care about all these changes there. I want to save my values, the one shown in black, right? That's what I know is correct. I'm going to take time. I'm going to make sure everybody knows, yep, that's the correct value. I can click save, and there we go. So now I've successfully updated the record with what I know is the correct values, right? And there we go. We've successfully given tremendous amount of feedback and options to the user. Can we do any better than that? Well, we'll wait and see, but I don't think so. Nothing off the top of my head. All right. And that finishes our discussion of concurrency.